Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 22 of the December daily LeetCode challenge, and we again have a hard question. So this is the second hard question in a row that we are having. Yesterday also we had a hard question, but that was on the simple side. And again today we have a hard question, and I will say like this is again a tricky question. But yeah, once you like know the logic of what is happening, you will feel that this was slightly on the medium to easier side. I will say that. But yeah, like it's difficult to find the trick. But once you get it, you will feel that yeah, this is nothing much. Like here there is no like very difficult algorithm being used. It's very simple thing only. We are using simple data structures, but yeah, that idea has to you have to click that idea, otherwise it's difficult for you, I will say that. So coming to today's question, it is 2940. Find building where Alice and Bob can meet. Okay, so if you see the input what we are given a heights array, we are given some queries are having like each element of the query is having two variables. Okay, so like for example, if you see 0 and 1, these are the two members given for each element of the queries. Yeah, these are the only two inputs, and you have to return a answer whose length is same as that of the queries. Okay, that is for each query you will have to return one answer. Okay, now let's see what the question is. So you are given a zero index array heights of positive integers where heights of I represents the height of the ith building. Okay, so these are the heights. So these represent the height of the ith building. If a person is in the building I, they can move to the other building J only and only if I is less than J and heights of I is less than heights of J. So like please understand this point very clearly, because the whole question is going to now revolve around this. So for example, see here, let us say I am at let us say I am at 4. Okay, now I can go to any other building towards his right. Okay, I cannot go to any other building towards his left. Okay, so one thing is very clear: if I am at 4, I can only go to buildings which are at right of it. Okay, first thing, that is the what the first condition is. Okay, so I should is only if I is less than J. Okay, that's for the time. So we have to go to J. We are currently at I. Okay, so let us say my I is currently this particular one. Okay, so the index one which has a value 4, this is my I. Okay, so I can go only towards his right. That is the first condition. The second condition says that you can only go to that particular height for which, let's say, you can go to only that particular tower for which the height is greater than the current tower. Okay, that means I can either go to this, or I can go to this, or I can go to this. Okay, but I cannot go to 2 because the height of 2 is less than the height of the current tower, so you cannot go to that. Okay, so you can go to either one of them or this one. Okay, so there are three options for you now. If you are at starting from 4, you have three options. Okay, that is what they're trying to say. Okay, just read this part again. If you are at building I, then you can move to any other building J if and only if I is less than J and heights of I is less than heights of J. Okay, as simple as that. The building that you are going to should have a height which is strictly greater than the current building. At the same time, you can only move towards the right. Okay, that this the target building J should be the index of the target building should be greater than the index of the current building. Okay, as simple as that. These are the two conditions. Accordingly, you can move. We are also given another array called queries where queries of I is equal to A of I comma B of I. What that means, on the ith query, Alice is in the building AI while Bob is in the building BI. Okay, so they are just giving the positions of Alice and Bob. Okay, the first index refers to the position of the Alice, the second index refers to the position of the Bob. Okay, the position of the index in which Bob is present. Return an array answer where answer of I is the index of the leftmost building where Alice and Bob can meet on the ith query. Okay, that is, these are various positions for Alice and Bob. Okay, so each of them represents the position of Alice and Bob. So for example, this is the position of Alice and this is the position of Bob in this particular query. So in the other query, this is the position of Alice and this is the position of Bob, and so on. Okay, so they're asking you the index of the leftmost building where Alice and Bob can meet on the ith query. Okay, so for example, let us see one example here. For example, let us say this part. So they are saying 0 and 1. Okay, so what are 0 and 1? See, let us Alice is in this particular tower and Bob is in this particular tower. Okay, so now, see here, this 6 basically means that this particular person, that is Alice, can only go to towers which are at right of it at the same time which are greater than 6. Okay. Similarly, Bob is at tower which has a height 4. That means he can go to the tower which is at right at the same time which has a height greater than 8. So if you see here, the number 8 satisfies both of them. Okay, the person from 6 also can go to 8, the person from 4 also can go to 8. Okay, so this is one potential answer for that. And remember, that's what they're saying, the leftmost building. So in this case, this is the leftmost building because it is just after 4. Okay, as simple as that. So the answer for this particular query is going to be 2. Okay, why 2? Because 2 is the index for this particular building, and this is one of the possible targets where they can go, and because they have mentioned leftmost building, so this becomes the only target where they can go. Okay, as simple as that. Remember, both of them will have to go to a different building to meet. Okay, so how they are going to go, they have to follow these conditions. Okay, both of them, from their current building, they have to follow this particular position, that is this value constraints to go to the right building. So yep, that was all about it. You can go to the example one. Okay, see, there are so many queries here. Let me take another one so that you can get some insight of it. Let us talk about this 0 and 3. Okay, so 0 means the height is 6 and 3 means 0 1 2 3 and height is 5. Okay, now So for example, see, this is the one and this is the other one. Okay, 5. As you can see, the one which is greater than 5, that is from the right of 5. The one which is greater than 5 is 7. I can see only this one. So this is going to be the answer. Okay, the index of this is going to be 5. Okay, as you can see, the answer is 5. So I hope you now understood the question. I can give the link of this question in the description. Just go through it and understand it once. I do not think that there is much for you to understand here. It's very, very simple. It's very, very straightforward. Only difficult will come is how you are going to program it. Okay. So we will see that how we are going to program it. The approach that I am going to follow is basically going to revolve around the topic of heap. Okay. We'll see that how. So see here what you are going to do. First of all, I'm capturing the length of both of them. See, I am going to show you both Java and Python solution for this. So just bear with me. I will show you both of them, and then we also understand the space and time concept of both the solutions. So I'm just capturing the the length of queries and the length of heights. Okay, simple as that. Then I'm creating an answer array whose values are going to be -1 initially. Okay, because remember one thing they have mentioned is that if they cannot go to a common tower, you will have to return -1. Okay, as simple as that. So for that reason, I am going to initialize all of them with -1. Okay, fine. Then I am going to create a query store. What this query store means, see, you will have to understand this. Currently will not make sense, but later on when I am going to show the other part of it, yeah, for example, this part, that particular time it will make sense. Okay, so for now you can just skip for this particular part. We'll come to this when we are discussing the other part. Okay, then I'm going to create a mini. This is actually like as you can see from the name itself, this will work as a mini. Okay, we'll understand what is needed. We'll go to that. So before that, I will show you this particular part. Okay, fine. So what we are doing, see, one thing is very clear. See, what I'm doing first, see, one of these indexes is going to be the smaller one, the other one is going to be bigger one. Okay. So first of all, we'll try to segregate them. That is always, let us say here we are the indexes. So I want always the bigger index to be the B and the smaller index to be the A. Okay. So that is what I am doing it here. So if you see, I'm just segregating which is the minimum value and the maximum value. The min will always be called A, the max will always be called B. Okay. Then so this is where we can get the answer directly. Okay, these are the only cases where we can get the answer directly. So what is that? If A and B are same, okay, as we can see here in the last case, okay, in the example one, the last case, the last query, both A and B, that is both Alice and Bob, are in the same building. In that case, they need not go to any other building. Okay, that is the first condition. The other condition is that height of B is greater than height of A. That is, you can think of it like this: the B is having a higher index. Okay, remember that part. So of the two, for example, in this case, if you see 3 and 4, the 4 is going to be B, the 3 is going to be okay. So always the bigger one among the two is going to be B. Now, since the height of B is also greater than height of A, okay, in this case, that means A can go to B and that is all. Okay, they don't have to go to any other building. For that reason, the answer for this particular query is going to be B. So in either of these cases, the answer is going to be B. Okay. If this is not true, that if this condition is not going to be true, what we have to do, see, now one thing is very clear, we'll have to find the answer ourselves. Okay, we are not going to get through this simple hints, we are not going to get the answer. So what we have to do, see, try to understand this fact. I will have to start searching after B. Remember, B is the bigger index of the two. Okay, B is going to be the bigger index of the two. Okay, yeah, as we can see here, the bigger index. So what do you have to do? We have to start searching it from the Bth index onwards. Okay, in the heights, the Bth index onwards we have to search. So in the query store, what I will do is in the index B. See, as you can see, the query store is having all empty list. Okay, for all the n. What is n? Basically, n is going to be the heights. Okay, so for all the you can say like the length is going to be n. That is for each index of the heights there is a empty list present in the query store array. So in that empty list, what we are going to append, we are first of all going to the index B in the query store. What is B? B refers to where we have to start searching from. That is, we have to start searching from B plus one onwards. Okay, as simple as that. We have to start searching for B plus one onwards in the heights array. So that's why in the index I'm going to go and append this particular value. This whole is a single value. Remember, this whole whatever I'm highlighting now is going to be a single value. Okay, this will look something like this. Okay, first of all, let me show you how it is going to look so that it will make sense for you. So as you can see, like this is how it will look basically. Okay, as you can see here, this is how this is going to be a single element, this is the second element, and so on. Okay, this is how it is going to look. So yep, like what is this basically? So see here, we are going to store the max height of both actually the index A and B. Out of them, whichever will like go to the heights of each of them. There's heights of A and heights of B, and which is the maximum height that we are going to store. Okay, why we are needing that? See, trying to understand the we have to start searching for index B onwards. Okay, that is there. So that is being pointed by this. Next thing that we need to like know what height we have to search for. Okay, so we have to start searching for index b, and at the same time we have to search for a height which is greater than the height of the max of them. Okay, so this particular value will show me at what height I have to search for. Okay, as simple as that. And the second we find such a height, we will have to append the index for that particular height in this particular index on the answer. Okay, so this is going to tell me, so this particular query is for which index. Okay, this is the query for ith index. So once we find the answer for this, we'll have to go to this index and make the changes. Okay, this for that reason. Now I will just print this and show you how it looks. Okay, then we'll go for the rest of the part. See here, initially the array answer is going to look like this. Okay, as you can see here, only for this particular element we are having answer. For rest of them we are having -1 at this particular position. Okay, because if you see here, this is satisfying that condition because in this both ls and bob are in the same building, so they can meet there itself. They don't have to travel to any other building. So this itself is going to be the answer for that. Okay, the other thing is this is going to be my query store, as you can see here. Okay, let me explain one of the queries. For example, see this part. This tells you that the height they have to search for is going to be 8. Okay, the height they have to search for is going to be 8, and the index, that is the index of the query, is going to be 2. Okay, so once we know the answer for this, we'll have to come to index 2 and mark the answer. Okay, in this case, so if you want to understand what it is, see, we have to go to query number 2. This is a query number 2. Okay, here the values are 2 and 4. Okay, here the values are 2 and 4, so we have to understand that what is 2, and the number 2 is 8 and the number 4 is 2. Okay, that is why 8 came here, because 8 is greater than it is maximum among the two. Okay, so 8 came here. So the idea here is very simple. See, we'll see 0, 1, 2, 3 and 4. So this is basically the index 4. Okay, that is for all of these queries. Okay, for all of these queries we will have to start searching for them when we are at this particular index. Okay, this particular index is 4. So once we're in the index 4 of the heights, we'll have to start searching for a element which is greater than 8 in the first case, and a element which is greater than 5 in the second case. Okay, so this particular 8 and this particular 5 means that. Okay, as simple as that. Now the other part of the question. Now we're doing the actual search. Okay, what we're doing next, I'm going through each element of my heights. Okay, I'm just going through each element of my heights, what I'm doing next. So this particular while loop will come at last. Okay, so we'll try to understand this at the last, but before that, just see the other part. If for the while, you see the for loop part. In this, what we are doing, we are going through each element in the query. So that is, we are going through each query. Remember that we are going through each query which is supposed to start at this particular index. Okay, as similar as that, and then we are just pushing that query. Okay, see, just we are fetching the query for that particular index. Okay, and we are just pushing it. Okay, as simple as that. You're just pushing it. So what this query basically means, the idea here is very simple. Once, see, if you see the query how it is looking, this tells me that this is the, remember, this is the index 4. Okay, this particular thing whatever you're seeing here. Okay, just a second, let me highlight properly. Yeah, this is index 4. Okay, do you agree with me? This is the index 4. That means once we are at index 4, I need to start searching. Okay, for these two. See, the answer for these two will come only after index 4. That is the something that I want to tell you. Okay, so after index 4, we have to start searching for the element which is greater than 8 and element which is greater than 5. Okay, once we get them, okay, the very first element that we get them, that is going to be the answer. That answer we'll have to mark in these indexes in the answer. Okay, this will be answer 2. This will be, that is the index 2. This will be index 3. Okay, and so on. So that is what we're doing. So once we reach an index from where we have to start for searching for the answer for that query, we will be pushing the query into the heap. Okay, simple as that. Next, for the first time when this particular for loop is run, okay, so this while loop will be empty, that is heap will be empty in that case, so this will not be executed. We'll directly come and start pushing the elements in the heap. Okay, and then on, what will happen is there will be elements in the heap. So what we'll do next, in the next iteration onwards, we'll check whether the heap is having elements or not. If it is having elements, then we are just trying to see if you see here, this is the zeroth element of it. Okay, this is the zeroth element of it. As you can see here, I'm talking about this. Okay, so this tells me the height and this tells me the index. Okay, so the zeroth element is the height, the first element is the index. Okay, the target index. So that's what I'm doing. First of all, I'm just checking whether this zeroth element, that is the minimum most element. Remember, the once in the heap, whenever you push, it will do the sorting. Okay, heap is basically a tree structure, right? It will do the sorting. So always the zeroth element will be the element will be the smallest value. Okay, so I'm just going with the zeroth element. I'm just going with the zeroth index of that element. Okay, that is, this tells me the height. Okay, the height. So if the height is less than the height of the current index, okay, that means we have found the answer. Okay, so what I will do, I will just do a heap dot pop. I will capture the values. Okay, being popped. So this value tells me the height. I don't need the height anymore. I just need the query index. I'll go to the query index and I will, the what is the current index, that I will mark it there. Okay, so this will be the answer of this particular index. Okay, so that is how I'm going to get the indices. If let us say we are not going to get the answer of one of the indices, that will remain -1 because we initialize the answer with -1. So if you see here, after submitting, this is how it will look. It will be like giving this particular output. Okay, initially it is like this, and at last this will be giving this kind of outputs. Okay, so why this works, basically the idea is very simple. See, I'm sure that in first attempt we will not be understanding this, but see, try to understand this idea what is happening. The idea here is, for example, if you see here these two values, these two will be searched only after reaching index 5 onwards. That is, they belong to index 4 in the query store, but we'll start searching them from index 5 onwards. Okay, whatever way they are present, if you see here, after once we are at I, once we have processed this, only then we will add these values. Okay, so this will be processed, whatever we're adding in this step will be processed in I plus 1. Remember that. So that is the basic idea. So this tells me that the highest height is 8. This will start searching because this belongs to index 4. So we'll start searching for height 8 and height 5 at index 5 onwards. Okay, And once we have the answers, we will go here and write that particular answer there. Okay, as simple as that. So this is what is the question, and talking about the space and time complexity of it. So first of all, the space complexity wise, see here, this is going to consume the space, it is going to O of q. This heap on the worst case will have q elements. What is q? Q is going to the length of the queries. And now coming to query store. Okay, query store, in the worst case, first of all, see, there is an empty list for each of the n elements, which represents to each of the corresponding elements of the heights. And for each of those empty elements, we could have multiple queries. Okay, for each query, basically we could store in any of the heights. Okay, that's any of the values corresponding to each of the heights. Okay, but this is literally O of n plus q. Okay, as simple as that. Remember, this is how it will look like. Okay, so the idea here is, in a single element itself we could have multiple values, and that the limit is going to be n plus q. Okay, as simple as that. So that is why this is going to dominate, and the space complexity will be O of n plus q. Okay, now coming to the time complexity wise, see, this particular thing will take O of q time. Okay, because we are processing q queries. Coming to the other parts here, this is going to take O of n time. Now I'm going to tell you separately about heap. So try to understand about heap. You are going to, for each element, that is for each query, you are going to push. Okay, and you are going to pop only once. Okay, each query basically you are going to push and pop only once. So for that reason, it is going to be q log q times. Okay, each query you are going to push and pop only once. Okay, push and pop takes log q times, so it will q into log q time. Okay, as simple as that. Other than that, if you can see, we are having these things also. So this is going to take O of q time, this is going to take O of n time. Okay, so writing all of this together, this is going to look like this. Since q log q dominates over q, so it will be n plus q log q. Okay, one thing. Now if you see the constraints here, yeah, so see, heights dot length is going to be around 5 into 10 power 4, and q dot length is also going to be same. That is n and q are almost same. Okay, in the worst case, both of them are having the same range. Okay, because of that reason, we can say that q log q will dominate over n also. So at last, we can just add q log q, because remember, q and n are almost same. Okay, they are interchangeable because they are having the same limit after all. Okay, for that reason, in the worst case, if you are talking about, you can ignore q n and you can just write in terms of q. In this case, since q log q dominates over any other term in this particular uh, the limit. So the reason is q log q will be the final one. Okay, so the time column will be q log q, and the space column will be O of n plus q. Okay, this was the Python solution. Exact same thing now we'll do in terms of Java. So let's see how we are doing that. Java will be, like I always say, first of all, think about the logic, the pseudo steps of it, the algorithm of it, and then choose the programming language. Okay, see, Java and Python, you can do the same thing, but yeah, Python will take, less lines of code, so it will be easy for you to verify whether your logic is working or not. Java is going to take much more lines of code, and yeah, there is a high chance you will make some mistake or the other if you are not very proficient in Java. So my request will be, like, learn both of these languages. They are both very, very good, and both have a lot of future. Okay, it's always good to know both of them. Okay, instead of just being sticking to one particular language. Knowing Java is great, but remember, Python can do the same thing with much better ease and much less time. Okay, and I'm saying in terms of writing. Okay, and if you also compare, like, let us say you take both of the solutions of mine, the Python and Java one, when you submit them, you will see that Java is faster in terms of time taken, but yeah, the space that is being required, okay, is much higher compared to the Python solution. Okay, so for that reason, I prefer Python, but yeah, it's always better to know both of them. So what are the libraries we are using? See, we are going to put the star of util. Okay, that is, we are needing all the classes defined in util. Okay, because we are doing multiple things. For example, the arrays we are using, we're also using the priority queue and so on. Okay, for that reason we need it. Now, why we need the math library? Math library we need because we are using that the max function. Okay, simple as that. For the math function, we need the math library. Okay, remember, max is static functions. For that reason, you need to write math.max. Okay, this thing I have told in multiple videos. So this is the reason why we need to write math.max. Okay, you simply cannot write max function as it is. Okay, we always have to write math.max. Now, so if you come to this solution, just here, the exact same. Okay, I've kept the names also same so that you can get it. The same solution you can work for you. See, first of all, we are filling the answer array with -1. That is all the elements in the answer array will be having -1 value. Okay, then we are declaring the query store. So see here, this is how the query store is going to look like. There's a list. Inside that, first of all, there will be empty list, and each of the empty lists can have multiple other lists. So for that reason, this is going to look like this. Okay. Then what we are going to do initially, like, we are going to fill empty list in all the indexes. Okay, as simple as that in the query store. Next, we're declaring a priority queue. In the priority queue, we are giving a comparator. This is going to be the comparator basically. So what you are seeing is you always have to compare the zeroth value of it. Okay, as simple as that. The reason of it I have already shown you in the Python solution. Okay, fine. Next, this part is very clear, like, we are just seeing, and if we are able to find the answer. Okay, if this condition is satisfied and we are able to find the answer, we are populating the answer in the answer array. Otherwise, we'll have to add them in the query store. Okay, this part I've already explained the Python solution, so I'm not going to detail of it. Next comes the same part. we are now starting, that is we are going to each height, and for each height we are just trying to check whether this could be one of the answers for any of the queries. Okay, this is what we are going to do. So this part will come next. Okay, at last, the while part you can just ignore for now. Always remember, the first, when the loop is iterating, always this for loop will work first, and the while loop will not be working for the first iteration of the bigger for loop. Okay, this particular for loop. So when the heap is empty, this for loop will not be functioning. So we are first of all going to add the values, and after that we are just going to, like the next iteration onwards, we are going to do this. Okay, till the heap is not empty, we are going to see the highest, that is the 0th element of the heap, whether the height of it is less than the height of the current element. If it is so, we have found the answer. Okay, just take the index from the heap's first element and make I as the answer for that. Okay, so this will the get of one will tell me the index in which we have to do the populate the answer, and I is going to be the answer for that, and then the pop that element out. So the pop is basically the poll in Java, and the peak function is actually, the peak is the right word. Okay, peak is just to get you a glimpse of what is there in the top. Okay, but yeah, poll is same as that of the pop. Okay, as simple as that. So yeah, friend, that was all for this particular video. So you can go through this Java story. I'm not going to in detail of it because yeah, I've written everything. So if you're good in Java, I'm sure you will be able to understand it. You just have to understand the libraries of how it is functioning, and the app, some of the functions of it, like poll and poll function, the peak function, and the add function, and so on. You have to just go through it. One thing that I want to show is that, see, in C++, what we're having, we are having a auto keyword. Okay, auto refers to the data type. It will predict the data type based on the way it is used. Okay, similarly, we have something called var in Java. Okay, for example, in this, if you see, this is actually going to be a list of integer, but I simply wrote var here. Okay, and it works. So this is something that you can think about and use it. So this will save you some time. In the cases where it's very easy to predict what is the data type going to be, you can use var. Okay, you cannot use it, for example, in these cases like this one, like this whole of this one, you cannot use var here. But in the cases where it is predictable, especially in the for each loops, you can think about using the var operator. Okay, for example, in this part you cannot use the var operator because it's first time being declared. But here, if you see, is the simple for loop. You're going through each element of the for this we are going through each element of this particular list. Okay, just a second. Yeah, this particular list. So what you can do is you can simply write where. So this will predict on its own, and we are going to use it. Okay, this is something that I want to show in this solution. So yeah, friend, that was all for this video. I hope you understood the video, you liked the video. We got something to learn from this video, though this question is marked hard, but we saw that with simple use of a simple data structure like a heap itself, we are going to get the optimal solution here. So yeah, I guess this was slightly difficult because to imagine the solution, to predict the solution, it's definitely difficult. You need some hints from the interview to come to this kind of solution. But yeah, the implementation part, I hope you will be able to do it if you have been doing LeetCode till now. So yeah, that was all for this day 22 of the December daily LeetCode challenge. See you tomorrow. Thanks a lot.